All right, so I'm back, and let's do the lab part. Um, so I'm going to leave this open because basically what we're going to do together is this, and this is a model build. This is a model builder example of that. So so this is implemented as a model builder. This is from the article. Um, so the input will be the elevation data set. The output is going to be three rasters that represent the x, y, and z position of the end of that surface normal vector. Okay. And so you can see, like, let's follow through creating the x data set. So we take the elevation, we calculate slope and aspect, and then we take the sine of the aspect, multiply it by the sine of the slope to get the x position. Okay. So that's the output right here, the x grid that we're looking at. And so the way that we follow that through is we take the slope and the aspect, and then the only difference between this and this is that the cosine and sine functions require that we compute between degrees and radians. So we have slope in degrees, we convert that to radians, and then once we have the slope in radians, then we calculate the sine of the slope and the sine of the aspect. My geometry teacher in high school said, remember, it's not the sin of the aspect. And then you calculate the sine of both, and then you get the x grid as the output. So the z grid is just the cosine of the slope. So that's why that one's not over here, because it's x, y, and z. So we could implement this as a model, or we could implement this as a raster function chain. I don't know that I obviously implemented it as a model at one point, but I'm fine either way. I think since we just did raster function chain last week, I'll do it as a model, and then we can talk about a little bit more about model builder. That sounds good. And then here you're going to implement this on your own. Now this is actually not super difficult. This is just going to be one step. So it's going to be a simple model. You're going to use a raster calculator. Oh, sorry, two steps. So you're going to use raster calculator to calculate to do zonal statistics as table, because these are just sums. So you're going to get the zonal sum of z, y, and x. Okay, so we'll talk about that, though, when we get to that point. Let me get the... Okay. Usually this is red when I'm recording, so I was a little worried, but it says I'm recording. I'm going to go ahead and say share my desktop one more time to make sure it's doing that. Okay. 418, 518, and then we're on this lab right here. So this is the reading that I referred to in the lab, but if you haven't read it yet, you can read it sometime. By the way, there's three parts to this lab. So the first part of the lab is to calculate the slope a few different ways. Okay. So we could do a little bit of that together. But basically what we're going to do is using raster functions, we're going to calculate slope using the focal statistics and other tools. Okay. So task 1 will be for you to, so this is the task that you're actually going to do. Task 1 will be for you to run, okay. Now let's download the data first and then we can walk through. The second part of this is, I don't think I've asked you to do this in this class yet, maybe except for the very first one, maybe. The second part of the lab is going to be you doing a ESRI training. And if you can log into ArcGIS Pro, you can log into this. So you hit sign in, you sign in, and it's basically just going to be an exercise. So you launch the course and you follow it through, and at the end you get a certificate that you'll take a picture of and send to me. It's just following some of the basic spatial analyst tools. Now for the other two parts of the lab, you're going to use the Mount Shasta data. And that is a separate download. I should have put it in the lab, but it's right here. Terrain data for Mount Shasta. So click on that and then download it. So I'm going to copy this and put it wherever you want. I'm put it in CTemp. And then I can go into ArcGIS. I'm going to close this map up. I'm going to save this. I'll close this map up. So this is what it would look like if you just opened. You could say I wanted to insert a new map. And in catalog, if I want to reference that location, I could go to databases and say that I want to create a new, or sorry, I want to add a database, not a new database. So C, temp, and I just call it terrain. It's not there, so I'll hit refresh. Now it's there. So I've only got two data sets here. One's called Shasta and one's called zones. Right now it doesn't look like Shasta's pulling up, right? So I'm going to change the symbology. Instead of, oh, I'm on zones. Change the symbology. There we go. I wonder why, was it on none before? Change it to min max. No, it was on percent, no, standard deviations. I don't know what it was on before, but change it to one of these. Oh, it was on percent clip. So change it to min max or standard deviation, something that actually shows the differences there. So can you see the volcano? So this is it's a big volcano. If you turn off the layer, the base map shows it too. Here's Mount Shasta. You can even see some old flows, some old lava flows, right down the mountain. It's pretty interesting. Okay. So what we want to do is we want to do this, create this part right here. So ArcGIS by default will create a toolbox for every project. So there's going to be a toolbox called week5.tbx. That's where it is on disk. So if you want to send that in later, you can get to it there. So I'm just going to go in here and create a new model inside of it. And I'll call this model, whoops. I want to rename it. Right click. It doesn't say rename. Anyway, I don't have to rename it, but I'd like to call it something besides model. Maybe under properties, there we go. So I'm going to call this create normal vectors. And ArcGIS, this is one thing that does not allow spaces. So if I put a space there, it'll give me an error. So. I don't know why it didn't. I don't know why it didn't update the over there. Okay, so I have my model over here though. Okay, I'm gonna hit save. I'm gonna save my project and save. Oh, there we go. Create normal vector. It got saved. Thank you. All right, so hit save right there to fix it. Okay. So this is the sheet where I'm gonna do this, and I already have it laid out here. Okay. So what I'm going to do is the first thing that I'm going to, and this was created in an earlier version of ArcGIS, but the same tools are going to work, but it looks a little different than the current version of ArcGIS. So I'm going to drag a slope and an aspect tool onto this model. So if I go to geoprocessing and I type in slope, and I drag that on here, and I drag on aspect, I've got both the slope and the aspect data sets there. Now, what I want to do is, what I can do is drag on this Shasta layer, and that will be the input raster. So I could go ahead and rename that, input, if I wanted to, and then I could make that right-click on it and make it a parameter. I'm gonna hit save again. Now I can feed that into the slope tool and and what it does is that I want to make that the input raster. And then I'm going to feed it into the aspect and also make it the input raster there. What's that? Okay, so I'm going to delete this. So I'm going to click inside of here and drag out to aspect. To what? Oh, well, I just changed the name of it. I dragged Shasta onto here. And then I right-clicked and renamed it to make it general. Okay. So if I wanted to make this look like this, I renamed those slope output. So I just renamed these slope output, and I'm going to rename this aspect output. So I have that set up. Now if I ran this, it would actually run this and store those values there it would store them in that location right there. So it's the default database for my project. And it's going to call it slope underscore Shasta 1 or whatnot. It used something that I just thought of. So there is a way to make an output be stored in memory. And it actually used to only work with vectors, but they changed it to work with rasters. Let's see what version they did, because we don't all have the same version here. So we can, new memory is a new memory-based, so we could say memory slash. Okay, memory based workspaces do not support geodatabase elements such as feed. That's fine. Since storing your system's RAM. Basically, well, I guess if you don't have enough RAM, it could be a problem. But it's kind of like how raster works. You guys don't do this. I'm just going to see if this works. I'm going to say memory, and then say everybody on the coast is still okay. Memory, and then call this slow. And I'm just going to see if this will work. If it doesn't work, then we'll just go back to the way it was. Yeah, memory aspect. Okay. I'm going to validate this and run it. It does look like it. Oh, executing. See if it works. Oh, it says it's succeeded. No, it says it's executing it. Well, anyway, that is working pretty slowly. I don't necessarily like how slow it's working. All right, that was an experiment. So the way I could change that back is to just say I want to be the home data set. And call this slope. Save. And call that. Now this will be like yours. Okay.
Error message. When I click on the aspect of the slope next to the input roster, it says this tool is not licensed. Like I had this is Shasta right there, and it just says input the tool is not licensed.
Okay.
It's like I hooked it up everything like you did, but it's not turning the color like it's you can be wrong or anything.
Right. Did you get the spatial analyst tools? Well, you should be licensed for all of them, but maybe for some reason it didn't include the right license in your particular case. So did you drag the 3D analyst one on or the spatial analyst one?
I don't remember. I would try.
That's the first thing I would check.
Do I need the spatial analyst?
Well, I almost for sure licensed you for a spatial analyst. I might not have licensed you for 3D analyst. I thought I licensed everybody for everything, but it's just more likely that
No, it's doing the same thing.
it's doing the same thing. Okay. Anybody else getting that error that says it's not licensed? Okay. Oh yeah, everybody has 2 days left. That's fine. What's your email address again?
Andrew.Patterson.
Actually, I think I can just get it from. Yeah, I forgot to check this box for you. Sorry. All right, you're all set now. I mean, it might take a few seconds, or maybe even have to log in and log out. But yeah. All right. Okay, so next we're going to go here. So we're going to convert our slopes to degrees and to radians. I mean, from degrees to radians. Now, this isn't a tool. I don't think there's a degrees to radians tool. Nope. Or maybe there's a radians tool. Nope. But degrees to radians is just a constant. Degrees degrees to radians. There it is. So 1 degree is 0.174533 radians. Okay. Oh, another thing is that we should make sure that these slopes are going to be calculating in degrees. I mean, they are. That's the default. But we don't want percent. Okay, so what we really want to do is just times. And we're going to multiply both of these by that number. And we could, the way I had it set up in that on that here is that I have one constant there. So the way you create a constant is under variables. Just click create a variable and make it a. We want to make it a double. What's called a double. That means that it's a number that ranges, that can be any floating point number, and it's kind of the biggest floating point number we can get. So what we want to do is connect the slope output to the times, and connect the aspect output to times, and then connect this double to the times, and then connect it as number 2, and then connect this double to that times as number 2. And then we can click into it and give it that number, 0.0174533. So that is going to be a number, and then everything will show up colored again. And if you want to probably because you selected, here, I'll delete this line for you. When I went like this, if you selected constant number 1, it'll remove that. But if you select constant number 2, it'll leave it. Yeah, what's your question? Up here under variable. I created a variable, and then I made it a double, like that. There's another one. So what's going on here is we're going to take the slope, then we're going to multiply it by this constant. And so what are these values? Well, this right here is, I'm going to rename that. It's the slope in radians. And I'm going to rename this the aspect radians. Yes?
Whenever I did the double for the arrows, it didn't go yellow or blue, it just stayed gray.
Did you put a value in the double? Double click on the double,
Okay.
and then put a value there, 0.0174533. 0.0174533. If you Google degrees to radians, you'll get a value there. All right. Okay, so now I've got that. I'm like halfway there pretty much. So I'm right here. Now I'm just going to take the sine and the cosine of each of these. So I need the sine and the cosine of slope and aspect. So if I type in cos, COS, I guess is what I should say, drag that on, drag on another one because we're going to do that twice, and then we're going to do sine twice. So the slope is going to go into the cosine, and the slope is going to make sure you select input raster. The slope is going to go into the sine. Make sure you select input raster. Aspect goes into the cosine and into the sine. So what we're doing there is we'll have a cosine and a sine for each one. Now the cosine of the slope is going to be the z. So I'm going to make that a parameter. So right click and say parameter. And then I'm going to rename that. I'm going to just call it z. None of these other ones are outputs yet. Okay? We still need to do something here. Okay? But what is that? Okay, well, I just said X grid, Y grid. What is it that we really need to do? Well, we need to multiply, to get the X grid, we need to multiply the two signs together to get the X grid. So these two signs multiplied together. So we need to type in times and then multiply these together. It doesn't matter what order they're in because they are, I keep doing that mistake that I said. It's going to go to 2. Okay. Doesn't matter what order they're in because they're multiplication. Multiplication doesn't matter the order. And so this one is going to be called, I'm going to rename this one X and make it a parameter. And then the final one, I go back to here, it's the cosine of the aspect times the sine of the slope. So this is the sine of the slope here. This is the cosine of the aspect here. The aspect, cosine. So I need to multiply those two together. So that'll also be a times. And again, the order doesn't matter since it's multiplication. And I'm going to rename that one Y. Now if I auto layout, let's see what happens. That's not too bad.
So you say the Y is cosine the aspect times the sine the slope.
That's right.
Right, okay.
Yep. And you can see that in the diagram here now. Cosine of the aspect, sine of the slope together in a multiplication make that value. I'm going to save this now. Right, so again, I said this would look a little bit different than this, but it doesn't look a whole lot different. We're still getting the X, Y, and the Z. We still have these two paths coming down. Still doing slope and aspect, sine and cosine several times, and that's the result. Okay.
How did you do organized?
I hit auto layout right here. Then I made sure I saved it. Okay. All right. Now at this point, you could close it, and then if you go back to the catalog to create normal vectors, if you double click on it, because you made those parameters, you can specify each one. So you specify the input. We do want it to be Shasta. That's going to be the default because we drag that over. But we could rename these values. We could call this, Z grid. We could rename this one X grid. And we could rename this one Y grid. And that order, we may not like that order. I think, I don't know if, I mean, I'm fine with the order, but I think we can change the parameter order. Yep, we can change the parameter order x, y, z. We can actually even change the default value. No, I guess it's not letting me do that. Say okay. Now when I double click that, I'll have x, y, and z in a. But you don't have to do that. That's just x grid. Y grid. I could go back and change these values in the model so that they would be the defaults. I'm in the tool I just created. I'll show you here. I'm gonna actually do what I said. So if I go to catalog, I'm in this tool that I created. But I had to save it first to get it that way. I'm gonna go back and edit it one more time. And in here, I'm gonna double click on Z, and I'm going to change this to Z grid, so that's actually the default value. And then double click here, and instead of being times sin XY, I'm going to change this to X grid, and then do the same thing here, Y grid. Okay. Just so that's just for cleanliness, like keeping sanity purposes. So if I hit save. I go back to the map, I double click on create normal vectors, then it's all set, ready to run. I don't have to set the cell size, by the way, like I did in this one, but I could, and I've done it in the past to show how slope changes, but I'll do it differently this time. We're going to go back and look at that. Okay, so here I've got my my data set. I'm going to run this, and it should run through. If yours doesn't run through, let me know. And also we can look at it in a second when we stop the formal portion of the lab. Okay. All right. So your output should look like this. So I've got my Z grid. That's this one. And remember, the Z grid, it's highest when the slope is the flattest. So if you think about that, I know that people at Stennis can't see me, but like imagine this is the surface normal vector. So if the slope is straight up, that's the highest it could possibly be. Anywhere else that slope is pointed, see how the Z value, the Z is this way, how the Z value goes down. So this grid represents the higher values, the ones closer to 1, are values that are close to flat in this Z grid. That makes sense. Like these areas way out here away from the mountain have the highest values closest to 1. As we get kind of close to the mountain, we get higher values because the Z is really tipped over. And the Z can actually never, theoretically it could equal 0, but because we're doing neighborhood slope, we can't ever equal 0 because we can never get a 90-degree slope, remember? Okay. So this is the Y grid, and this represents the degree to which the slope points north or south. So the higher values here represent more northerly, and the lower values are more southerly. So that's why this looks like a hillshade pointed straight up. See if it's close, the closer it is to a 90-degree slope pointed north, the closer it will be to 1. So the closer it is that direction, okay, in the Y direction. So these are steep northerly slopes, and these are shallow northerly slopes. These are steep southerly slopes, And we don't really have too many, but like maybe, I guess, that might be an example of some shallow southerly slopes. We don't have as many because it extends more in the northerly direction. And then finally, the X grid is the same, but it's going this way. So together, all three of these values, the Z grid, the X grid, and the Y grid, are the position of that surface normal vector. So if I click here, let's see, how in ArcGIS do you get all three of the, anyway. Oh, I got one way. This is not something I thought of doing, but composite bands. So I'm going to input the X grid. You don't have to do this. Y grid, Z grid. I'm just doing this to show what it might look like if I put it all into 3 different raster bands. Okay, so that's kind of pretty, right? And this is some way that our eyes can see all 3 variables at the same time. So anything that is white is high in all 3 values. I don't see anything that's really white, right? Anything that is red is high just in band 1, which I made the X grid. So in other words, it's facing, anything that's high in red is facing east. Anything that is low in red is facing west. And as the colors mix, we can see something that's high in both. So if it's high in both red and green, meaning it's yellow, then it's facing northeast, because it's a mix between facing a high north value and a high east value. So you see some yellow right along here because it's facing northeast. Okay. Blue means that it's high in the Z, which means that it is a low slope area. So you can see this purple represents that it's easterly and blue. So it's easterly and shallow. Okay. Whereas there's not a whole lot of blue up here, which means it's steep. I mean, it takes a little bit to kind of to understand what's going on there. But if we click anywhere doing this one, it'll tell us the value of all 3. So that's the endpoint of the surface normal for that cell. That's the endpoint for the surface normal of that cell, and so on. So that's really why I did it, so you could see the. I know that there is a way to like do multiple rasters and when you click, but or multiple layers, but that seemed to be a little bit easier just in this case. Okay. So. That's what I meant to do, but that is a model. Okay, that's the model that you need that we created together in class. I can go ahead and post that model. The problem is that your sources will all be different. But all right. So what do you need to do to finish? Well, you need to implement. I already downloaded it, didn't I? Oh no, it's just in the. It's probably on one of these screens I already have open, but let's just find it again. It's just in the text of the lab. All right, so you're going to create a simple model that basically just has. It's going to have 2 steps. Now, I helped you out here because this is a pretty crazy formula, right? Okay. That formula is right here. And the reason this slide's actually cut off here is because you don't need any of these other two. Okay. So what you need to do, actually, let's change it. So I'm going to change it. You don't actually need to create a model if you don't want to. But each of these three are zonal statistics as table. Zonal statistics as table 1, zonal statistics as table 2, and zonal statistics as table 3. So you're going to have 3 tables. And each of them will have a sum column, right? You'll have a sum column in each one. And by the way, what are your zones? I guess I didn't talk about that. Well, yes, that's the value raster, but the zones themselves is this data set here. So these are just circular zones. So you're going to calculate the average slope in each of these circles. Okay, that's what you're going to do. Calculate the average slope in each of those circles. So these will be your zones. So you'll do zonal statistics as table 3 times. You'll do it once for the x, once for the x grid, once for the y grid, and once for the z grid. You do 3 times. So you'll have 3 tables. All right. How do we take those 3 tables and put them into a single table? Combine, but yeah, you're right. That's not the right tool. And it's not merge. Merge is the name of a tool, but merge will take the nope, you're right. It is actually no, it's not. You're right. So merge takes a table. I doubted myself for a second. Merge takes a table and stacks it. So we'll have the zonal statistics for each of those 9 layers, and if we used merge, we'd have those 3 times. Okay, that's not what we want. Yeah, it's join. So we want to join them so that they're stacked this way. So we're going to join them on the. We're going to join each of those tables so that they join on the zone number. I know we're getting kind of late here, but I could do that. So I'm going to do 2. I'm just going to do 2, and then I'll leave the third one up to you, just so that everybody kind of gets. I'm going to use the ID field, and then I'll just do this for the X, and then just a second. Don't do what I'm doing yet, because I'm going to see what this does. Sum. Because this would be faster than this couldn't end up being faster. Let me look at this table. Where is the table? Zonal stats, ZT zone. Oh, I did zonal statistics. Sorry, zonal statistics as table. Zonal geometries table. No, zonal statistics as table. All right, don't do this yet. I'm going to see if this works. Composite bands, output table. Okay, that's fine. We'll get rid of this because we don't even need it. Okay. I'm just going to say just the sum. All right. Nope, that didn't work. I was hoping that it would summarize that by. So this is summarized by zone, but I don't know what that sum is, because I was hoping that it would do that for each for each band. Yeah. So it doesn't look like it did that because it's just the one sum. So. Anyway, yeah, it looks like you're going to have to do it X, and then I would call this zonal stats X, I'm just going to do 2 for now. And then, so I'll call this one zonal stats Y. And make this Y. Run. Okay. All right. So I have those 2. Get rid of this one. Open this attribute table. Open this attribute table. So the numbers are different because this is the sum of all of the x's, and this is the sum of all the y's in that area. So you can see which ones on average, like this is the y, so this one on average was facing south. So it's probably, you know, that, it's probably that circle, I would imagine. Let's see. It's grid 3. So if I opened up this one, sorry, not grid 3, zone 3. So zone 3, no, it's that one. Okay. So it's on average, that one's just barely south facing. The rest of them are all north facing. Which one? Yeah, so what I'm doing here is this ID field is actually the equivalent of it's this ID field here. And so what I want to do is, what I could do is in this zones field, I can join both of these data sets into this data set. So then I could do a join, add join, and then say the join field is going to be ID, and I'm going to join the X table and say OK. So now I have all these sums on here. I can do that again with the Y table. And now I have a bunch more. Okay. So I have everything in the same table. I need to do that one more time with the Z table. Then I need to, once I do that, I need to create a new field called average slope, mean slope, and then I need to plug this big old formula into it. Now your fields are going to be named differently. So if I calculated a new field, there's 2 different sum fields. So when I click on it, it's going to say zonal stats x.sum. That's the x sum. And then zonal stats y.sum is the other sum. All right. All right, so when you upload a tool, we're going to change this. So you only have to upload this tool that I created. So I want you to create it too, and then I'll change it so that you have to upload this. You have to upload the table complete with the mean slope calculated. So those will be your 2 uploads. Okay. Or you can just send that column that has the mean slopes for that column. Yeah, but you still have to answer the questions. Give an example of one way the topographic vector concept could be useful in a modeling application. I did talk about that in the lecture. So if you can to restate that, I guess you're fine. You could also, read the article over, and probably really only need to look at the conclusions or the introductions and scan the rest of it, to come up with that. But it's not an extremely long article, so you could read it, the whole thing as well. All right. So I'm going to modify this lab, and actually I'm going to modify the last lab so that you don't have to do the accumulated cost. Okay, I'll just change it. So the easiest way to get accumulated cost is just to click on that cell in the cost raster, in the cost distance raster. Okay, so there's no reason to overthink that and to try to use the zonal data, which I was trying to find another way to use zonal. I'm still not exactly sure why that doesn't equal the same value. Thought it would, but all right. Any other any questions? Do you want me to help you as you go around and work on that? I'd be happy to do that.
So, excuse me, Dr. Raver?
Yeah.
So, since last week's lab is due tomorrow,
I'll change that to a couple days later or whatnot.
Okay.
But yeah, I mean, it's actually, I'm actually just taking off an assignment, so.
Yeah, I mean, I have the map made, so if you're just going to take it off, I'll probably just go ahead and upload that.
Yeah. Yeah, but I'll still change the date. I'll still change the due date to Monday, but basically,
Okay.
there's less of an assignment. So you're just not doing that last part where you're coming up with the total accumulated cost.
Perfect. All right, thanks. That's all I have.
Okay. You know, it might have something to do with the fact that the accumulated cost might have to be multiplied by the distance. We should test that. Anyway, any other questions? Okay. You want me to come help? Yeah. Okay, I'm gonna stop recording for now, and then, you know, if the needs arises, I can keep recording. I'll stay in here helping people out. If you all have questions, just you can ask them through this, or you can ping me either on Skype or through